We are told that dissolving sodium chloride in water is an endothermic process, and to answer the following questions. Does the surrounding solution become warmer or colder during this process? Why is this reaction endothermic? And why is the process spontaneous at room temperature? So first I'll answer the question, does the surrounding solution become warmer or colder during this process? So to answer this question, the key is that this is an endothermic process. So that means that we need to draw in heat and we need to draw in energy for this reaction to occur. And this contrasts exothermic reactions, which release energy. And a lot of the times that's why these reactions are written in certain ways. So for example, for an endothermic reaction, we may have A plus B plus heat goes to C plus D. And the reason it's written like this is because heat is an input. That's what drives our reaction. And for the exothermic case, sorry, this should be an R here, we have A plus B goes to C plus D plus heat, for example. And this heat actually becomes an output now. It's being released. So knowing that, we can then say that our surroundings get colder because to draw in heat, we need to take that energy from our surroundings. So our surroundings actually cool down, whereas for an exothermic reaction, our surroundings heat up. And then we can move on to answer the second question, which is why is this reaction endothermic? So we're really just being asked, why do we need to take in energy for this reaction to occur? Well, to dissolve sodium chloride in water, we need to break bonds. And to break bonds takes quite a bit of energy. And if you remember, sodium chloride is a classic case of an ionic solid. So it contains very strong ionic bonds, which means we need even more energy to break these types of bonds. And that's the reason why this reaction is going to be endothermic. So the last question that we can answer is, why is the process spontaneous at room temperature? So to answer that, I'm just going to take a look at our classic equation that relates G, H, and S. So we know that delta G equals delta H minus T delta S. And we were actually told this process is spontaneous. So by definition, delta G is negative. And we know our sign of delta H because we're told that we have an endothermic reaction. So if you recall, delta H is positive for an endothermic reaction because we're drawing in more energy. And for an exothermic reaction, delta H is less than 0 because we're releasing energy to our surroundings. So in our case, delta H is positive. So in order for delta G to be negative, given the sign of our delta H, we know that T times delta S has to be a very big number to dominate over our delta H. So we know that delta S should be positive and relatively a big number to dominate. And that gives us insight into why this reaction is spontaneous at room temperature. And the reason it is spontaneous is because delta S is the dominating term.